In section 2.4, we're going to go a little bit deeper into linear functions. In the last video, we focused on slope-intercept form, so today we're going to look at different forms of linear equations and where it would be appropriate to use them. So let's start off. Let's say you want to write an equation of a line that has a slope of 2 over 3 and goes through the coordinate negative 2, 4. If I'm only focusing on slope-intercept form, I'm going to kind of hit a dead end here, because while I'm given the slope, just looking at that information, I have no idea what my y-intercept is, and that's really crucial to be able to plug into slope-intercept form. So in a situation like this, a format of an equation that might be more helpful is point-slope form. Clearly here, because I'm given a point and I'm given the slope. In point-slope form, I would plug my slope in for m, and then my coordinate I would call x1, y1, and I would plug those coordinates in here. So for example, in this equation, I would write it down like this. I would do y minus my y coordinate that's given, which is 4, equals my slope, which is 2/3, times the quantity x minus my x coordinate, which is negative 2. Finally, my last step here, minus a negative changes to positive, so I'll go ahead and change that. So my equation in point slope form is y minus 4 equals 2/3 times x plus 2, and I would be done. Now, later you might be asked to put the equation in slope-intercept form in the end. From here, in 2 steps, we could isolate y and get that by itself. We'll see that in a later example. Another nice thing about point-slope form is that all you really need are 2 coordinates to be able to make an equation. Because as we learned in the beginning of this unit, I just need 2 coordinates to figure out what my slope of a line is. So in this example, we have a line passes through the coordinates 3, 2, and 5, 8, and I want to write an equation from that in point-slope form. So in this kind of a problem, first I want to find the slope, which as I know is change in y over change in x. So I can figure that out by writing 8 minus 2 over 5 minus 3, which simplifies to 6 over 2, which finally simplifies to 3. So that's my slope. From here, I need to choose any coordinate. Now, what's important to note here is that it doesn't matter if I pick 3, 2, or 5, 8. As long as I plug those coordinates in correctly with the format of my equation, I'm going to end up with the same line, even if it might look a little bit different. So here, I'm just going to go ahead and pick 3, 2. And when I plug it into my equation, first I'll plug in my coordinate, and then my slope. And I'm left with y minus 2 equals 3 times x minus 3. And I'm good to go. That's my equation in point-slope form. Now, before we move on, the last main form of a linear equation is standard form. Standard form looks something like this: ax plus by equals c. An example could be 2x plus 10y equals 5. Now, I think that with that being said, if you had an equation like that example, I think it would be easiest to graph if you just put this into slope-intercept form, which is why we're not really going to get super into it. I do think it's important to have it written down, though, just so that you're familiar with what that format might look like. But from there, we're really not going to get too much deeper into it on like a test or quiz or anything like that. Finally, let's talk about parallel and perpendicular lines. Now, you probably talked about this in geometry, but we're going to cover it today. Parallel lines means that their slopes are identical. Parallel lines will never intersect. So they have different y-intercepts, they start at different places, but they go at the same rate, so they will never cross each other. The key here is that parallel lines have the same slope. On the other hand, perpendicular lines have slopes that are negative reciprocals of each other. To be a negative reciprocal means not only do I flip the fraction, but I change the sign as well. So a negative number would then turn into a positive number and vice versa. Also, perpendicular lines, just as a reminder, meet at a right angle. So let's end the day kind of tying everything that we've talked about into one problem. Here, I want to write the equation of a line that is parallel to y equals 6x minus 2 and goes through the coordinate 1, negative 3 in slope-intercept form. So when I read that, sometimes it might get a little bit stressful because there's a lot going on in this problem. So this is the kind of question where it's nice to think of a game plan. In this kind of a problem, first I want to figure out what my new slope is. So whether I want a line that's parallel or perpendicular is going to be helpful here. From there, once I figure out my new slope, I'm already given that coordinate, so I can plug into point slope form. Finally, after I have my equation in point-slope form, I can easily solve for y and get it into slope-intercept form. So let's do those 3 steps together. First, I want to find my new slope. So I'm given y equals 6x minus 2. That's in slope-intercept form. The slope will be that coefficient with the x variable. So I have y equals 6x minus 2. That means the slope of this line is 6. If I want a line parallel to it, that means I need the slopes to be the same. So if my original slope is 6, my new slope will then also be 6. So now, I have a coordinate, I have my slope, I can plug into point-slope form. When I do that, it's going to look like this. Y minus negative 3 equals 6 times x minus 1. Minus a negative, again, changes to positive. Step 2 is done. I've plugged into point-slope form. Finally, I want to solve for y or get this to be in slope-intercept form. The nice thing here is that it'll be the same 2 steps every time. So first I'm going to distribute, then I'm going to move everything to one side. So distributing, now I have y plus 3 equals 6x minus 6. Last step here is to get the y by itself. I'm going to subtract 3 on both sides. That cancels. So my new equation that I want here is y equals 6x minus 9. And I'm done. One more just to practice. I want to find a line that is perpendicular to y equals negative 4x plus 2/3 that goes through the coordinate 8, 5 in y equals mx plus b or slope-intercept form. Again, going through those same 3 steps. First, I want to find my new slope. So here, I want a line perpendicular. If my original slope is negative 4, or you could think of it as negative 4 over 1, the perpendicular slope would be positive 1 over 4. Now, I have my slope, I have my coordinate, I can plug into point-slope form. And it's going to look like this. Y minus 5 equals 1/4 times x minus 8. Finally, step 3, get this into slope-intercept form. First, I'm going to distribute. Then I'm going to bring the 5 over. My final equation in slope-intercept form would be y equals 1 over 4x plus 3.